Welcome to Engineering Innovations, the official podcast of the Elmore Family School of Electrical and Computer Engineering at Purdue University. I'm your host, Kristin Malavenda, the Communications Director for the school. Today we're joined by James Davis, Assistant Professor of Electrical and Computer Engineering. Jamie leads Purdue's Duality Lab, where he and his team explore innovative ways to enhance software safety and security, tackling challenges from problematic patterns in code to vulnerabilities hidden in software supply chains. We'll talk about the importance and potential pitfalls of regular expressions, the human side of cybersecurity, and why creating secure software benefits everyone. Thanks so much for joining me today, Jamie.
It's a pleasure to be here.
So let's start at the beginning. Tell us a little bit about your background and how you became interested in engineering, and then what led you to your interest in your current research focus.
Well, I'm sort of an accidental engineer. My undergraduate degree, I started out as a physics major, and then in my first year, one of the mandatory courses was an introduction to programming in C++. And I found myself procrastinating on all of my other homework and exams in order to do the C++ homework.
Okay.
And after about half a semester, I thought, wait a minute, if this is my favorite part of my week, maybe I should just do this as my career path.
Yeah.
So I switched from a degree in physics to a bachelor's degree in computer science, and I also got one in mathematics as well. If you take enough classes, they just give you another degree.
Take one.
Yeah, just take it. So I graduated from Clarkson University in 2012, and my first job was at IBM. I was a software engineer in the quality assurance or test division. That meant that my job was to write automated systems to find defects in other people's software systems.
Okay.
So sometimes when you think of tests, you think of a lot of like manual clicking. I wrote tens of thousands of lines of Perl and C++ code to do all sorts of funny things. So that's kind of how I got here. I really loved working at IBM. That job was fascinating. The coworkers were amazing. The mentoring opportunities were superb. But I was thinking about moving into more of a technical leadership role, and I thought, I should get a graduate degree. So I enrolled at Virginia Tech as a master's student. And my wife also enrolled there as a master's student. And we thought, okay, we'll get these degrees, we'll go back out, work in industry some more. And then we both really fell in love with research.
Okay.
And so after our first year of master's degrees, we kind of looked at each other and said, maybe a PhD could be good. So we switched into PhD programs, and one thing led to another. Here we are at Purdue as faculty.
Is she also an engineer?
Yeah, she's in engineering education.
Oh, okay.
So she studies how we help engineers think about the sort of broader systems level implications of the work they do, and also how their interactions work across cultures.
Interesting.
Yeah, we collaborate a bit, so it's been really fun to
that's great.
Pick her brain on things as well.
So I mentioned in the introduction that your research involves improving the safety and security of software systems. Can you explain in simple terms what regular expressions are? Why are they so important but also potentially problematic?
Yeah, so let me actually start with why I think that improving the safety and security of software systems matters.
Absolutely.
As a sort of starters, and then I'll talk about regular expressions. So I actually got into this space as a result of mistakes I made at IBM. So I am the proud co-owner of having caused a CVE to be announced in IBM's products. So back when I was working in test, a CVE is a cybersecurity vulnerability. It's the kind that a company puts out a public release that says, if you're running this version of this code, you should call us, and we'll try to help you fix it. And I was supposed to have noticed a certain kind of defect in the system I was working on, and I did not notice it. And eventually, we caught it internally, but long after we'd actually shipped the code.
Right.
So we're not aware of anyone who was harmed by it, but we did have to get the lawyers involved and write up a description of what could happen in the worst case.
Gotcha.
And so that experience really taught me how severe security and safety issues are for products, right? It matters when your code crashes, it's annoying, the customer's grumpy, but it matters a lot more if the customer could be vulnerable or harmed as a result of it.
Yep.
So you mentioned regular expressions. I've done a great deal of work on regular expressions, and maybe a simple way to understand them is as the front line of any processing of user input. So regular expressions are actually one of the oldest kinds of reasoning people do to describe how computer programs work. They date to back in the 30s and 40s.
Okay.
A gentleman named Stephen Klein was developing them. Kleina. Stephen Kleina.
Ah.
I learned from some Europeans last fall how to pronounce that properly. And this was roughly around the time that Alan Turing was doing his work on computing, and von Neumann and so on were setting up computers. So it was really old stuff. And it turns out that Kleina's work provided a really nice way to describe what strings look like.
Okay.
And we use strings everywhere when we talk to computers. When humans talk to computers, now we're getting into like you can speak to them verbally, but even that verbal stuff is often converted into strings and then passed to the computer to make sense of.
Right.
And so anytime you go into a website, you type in your email address, you type in your zip code, you type in credit card number. Half the time you make a typo and it turns red and it says this is not a valid email address.
Right.
Well, that happens not by magic, it happens by regular expressions.
Okay.
So a regular expression is a tool that says this is what an email should look like. It's got da 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 da, and then an @ symbol, and then a bunch of other stuff, probably a dot, and then a com or an edu or a mil or a gov.
Right.
So engineers write these things, and if they write them correctly, what they're able to do is exclude invalid input from their system. And so they only want legitimate looking stuff to make it through to further processing, to going to the database, to participating in database queries. If they write the regular expression wrong, then they can let malformed strings into the system.
Okay.
And that can wreak all kinds of havoc. So you've maybe heard of things like SQL injection or cross-site scripting. Both of those, you want to prevent them with a lot of different defenses. You want defense in depth, lots of safeguards. But one of the first lines of that defense is keep it out in the first place.
Right.
So if your regular expression is done carefully, you can keep those things out. And if you are a little bit too generous, too liberal in the strings it accepts, then you need to rely on other kinds of defenses. So getting the regex right really improves the sort of the security of the system. So that's called input sanitization. And there's a whole CWE, that's the common weakness enumeration, that's the taxonomy of all the security flaws in your system. One of them is improper input sanitization, which means you let bad stuff in.
Right, okay.
Now there's this funny thing that regular expressions do for all kinds of goofy historical reasons. And this is that you can write in many programming languages as of about 2017. Things have changed a bit.
Okay.
But as of 2017, when I started studying this, you could write a regular expression that on certain inputs would take years and years or infinite time pretty much in order to execute. So technically we would say it would execute in exponential time in the length of the input. That's a bad word, right? It's great when you're investing. Compound interest is nice, exponential growth, but it's a really bad word when you're talking about how long it's going to take the computer to process this input.
Right.
And since regexes are usually applied on the server side, there's a bunch of other clients that are all waiting their turn to have the regex match complete, and if one of those matches takes 1,000,000 years, guess what? We call that denial of service.
Okay.
So when I started this study, what we found is that most of the mainstream regular expression engines actually all had this property.
Okay.
So this is bad, right?
Yeah.
Engineers in any language can accidentally shoot themselves in the foot and end up with a regex that takes 1,000,000 years to evaluate. That'll happen because those regex engines, engineers don't like to throw things away, so they were all building off of a nice code base written by a guy named Henry Spencer back in the 80s and early 90s, and all the different programming languages basically copied, they forked that code base, and they added their own extensions, all these different cool operators, but they're all built on the same thing. And that engine, that algorithm from Henry Spencer, has an exponential worst case behavior.
Oh.
Now it's not good. It's not the only way to do it either. So the joke here is that the first published regex matching algorithm runs in linear time. That's from the 50s. Ken Thompson wrote it up. But Spencer said, well, that's, we need all these cool extra features, so let me use this other algorithm instead. And the programming language owners, all their different regex engines, also inherited those cool features, but also this Achilles heel, if you will. One of the cool things about the work that I've done that I'm very proud of is that I started doing these large-scale measurement studies to say, look, we've all known in principle this could happen, but in practice, is it really happening?
Yeah.
And I asked the regex engine owners, I said, hey, you're aware of this, right? And they said, yeah, of course, just don't do that. It's like you go to the doctor, you say, hey, doctor, it hurts, can I do this? And the doctor says, don't do that. Okay, well, that's fine if what you're doing is like backflips. Maybe you're 45, your backflip days are behind you.
Yes.
But from a software engineering perspective, if the typical engineer doesn't know about this property, which they don't, and if the typical engineer regularly needs to write such regular expressions, then it would probably be good if instead of saying don't do that, you just made the engine safer.
Right.
And so we did large-scale measurement studies and found that indeed 5 to 10% of the regular expressions that everyday engineers are writing have this property that they can be exploited in this worst-case manner. 5 to 10% is way too many.
Yeah.
Right. So we also asked the engineers, hey, are you aware of this? And they all said, what are you talking about? Because it's just not common knowledge.
Right.
It's also not documented in the Regex engine docs, right?
Oh,
So
well.
if you know about it, you avoid it, but most people don't know about it.
Right.
And yet they find themselves needing to express themselves in the way that can lead to this bad behavior.
Right.
So as a result of the research I did, many different mainstream Regex engines actually started changing their algorithms. So they said, okay, we're persuaded there's enough of a problem here that it's worth the engineering investment to fix it. So the folks at .NET, there's a guy named Steve Toop over at Microsoft, and he put in some cool optimizations using an algorithm that they'd actually invented over there. The folks at Google who work on the V8 engine, that's the thing underneath JavaScript and Node.js.
Okay.
They started rolling out basically the original Thompson algorithm. So there's two code paths. One is the really fast one, and that covers about 90% of the cases. And then there's this small set that they can't do perfectly, but 90% is pretty good.
Yeah.
And then the folks at Ruby actually took a paper I'd written and they said, that work is cool. We'll just copy that. So they just took it wholesale, and their pull request cites my paper. I was very excited.
Nice. Yeah, that's cool.
Yeah. So we recently redid our measurements, and the engineers haven't changed their practices. They still need to write these complex regexes because the real world is complicated, but the engines have changed. So back in 2017 when I started, almost all of them had this problem, and now if you look at the latest releases of the engines, almost all of them have been fixed. And so I find this very exciting.
That's awesome. Yeah, it's very like concrete thing to look at and see the impact of.
Yeah, I've put myself out of a job to some extent. So I recently actually published a paper that said more or less, hey, we kind of solved this problem, it looks like. Let's move on to other stuff.
Yeah, right. What's next, right?
Yeah, exactly.
Well, you talked about one example was, if you put your email in wrong and it tells you that that's wrong. That's not a dangerous thing to have happen. It's just annoying, right? Mm-hmm. What are some examples of some more serious things that could happen if the regex is wrong?
Okay, yeah. So there are regular expressions are used in lots of different contexts. So I'll talk about one that's actually taking the email one and turning it bad.
Okay.
Right? And then I'll tell you about one that maybe you'll recognize as that's clearly more of a problem. So for the email one, the concern is not annoying the user, right? You do need to have a valid email. And there are funny cases where what Gmail accepts is actually bigger than what the official internet standard says should be acceptable.
Okay.
And so you're like, this is my real email address, come on. And it just won't let you put it in, so you do something funny. But one of the concerns is called SQL injection. And so when you enter data into pretty much any web-facing system, almost all the time that data is headed off to a database for a query. So you enter your email, and they might go check the database and say, oh, you already have an account under this name.
Right.
You can't make a new one. Well, the way they check that is they take the email, they plug it into a database query that says, go get from the table of user accounts anything with this email in it. And if they get any hits, they say, you've already got an email or account here. And if they get no hits, they say, oh, good, you can make a new account. And so the hazard that can arise here is you write this database query that says select star from table where email is like, and then they insert the email address.
Okay.
And if they haven't been careful, what they insert is input from the user. And what that user can put in is all kinds of what are called meta characters that change the behavior of the system from executing the query to saying, okay, I finished the query, what else would you like to do? Mm-hmm. And so they can make that query that's supposed to be pick things from the database, and they can change it to pick things from the database, and then while you're in there, why don't you delete the database?
Oh, not good.
This is not good, right?
Mm-hmm.
Or while you're in there, why don't you go query the Social Security info table in case that exists?
Yeah.
Oh, it exists? Great. Why don't you just send that back to me? And so this is when you don't sanitize the input properly. Whatever you've got inside the system that you consider a sensitive resource, an adversary may be able to access, and they may be able to modify it. So this is bad news.
Yes.
Right. So that's one. That's like the improper input sanitization. What can it mean for you? It means that those things that you thought of as your jewels are now potentially compromised.
Gotcha.
Are regexes the only defense you should have? Of course not. But they're certainly the first line, and if you're not checking your input carefully there, you can run into trouble.
Yeah.
Now that's all the like standard user-facing web interfaces we're familiar with, but regular expressions are used in lots of other ways. So one of their most common use cases is for network routing and network packet monitoring.
Okay.
And so all the data that you're sending from your computer over the web, if the data you're sending contains things that look funny, the routers in between you and your destination may say, this thing looks funny. In fact, it looks like this attack that we heard about last year. And our engineers encoded a general description of that attack using a regular expression. So we're just going to throw the traffic away.
Okay.
Right? So you tried to send something malicious over the web, and something in between you and your victim is able to notice it and say, oh, we'll discard this.
Yeah.
And a lot of that is done using strings, right? Network packets are just strings, okay?
Yeah.
And when you're trying to analyze a string quickly, you usually turn to regular expressions. And regexes are used by the engineers. Usually this is done either in really high-performance regex engines or the highest possible performance regex engine, which is a hardware accelerator. So actually some network routers have on board a chip that is custom designed to do regex pattern matching. It's really fast.
Yeah.
But it matters that the engineer get the regex right. I mean, the chip can run as fast as you want to, but if it's searching for the wrong stuff, it's no
Right.
good. So the engineering activity there is, well, how do we write the regex correctly?
Gotcha. All right. So I mentioned that you lead the Duality Lab at Purdue. Is this the primary challenge you've been addressing? And since you've done so much work in that, what will you be looking into next?
Yeah, so I'd say that the lab's general goal is to understand failures in software-intensive computing systems and to work to mitigate those failures. And we consider failure a bit broadly, but you can think about, I read in the newspaper that this terrible thing happened and it involved software. How do we make that not happen anymore?
Gotcha.
So we generally invent new stuff, right? But sometimes the answer is as simple as, well, there are these existing standards that if the engineering team were following, that would not have happened. And so we're open to the answer being the engineers need to improve their process. But sometimes the answer is the engineers lack the capabilities to do this well, and so we need new capabilities. So both of those things are in play.
Gotcha.
Regular expressions are one place that we've worked. That's kind of where I did my dissertation work, and so that's kind of the starting point. But we work on a lot of different topics in Duality Lab. We work on things like software supply chain security. We work on how people exchange and manage machine learning models. We work on understanding how to formally guarantee the behaviors of embedded software. And one of the more recent things we've been working on is just kind of making sense of the software news, right? When you read about this thing that's failed and it says there was a software issue, to what extent can we pull data out of the public? It's called open source intelligence, which is a fancy way to say newspapers.
Yeah.
But how do we pull enough information out of the news to get some useful insight for engineers? So it's a pretty broad spectrum, but those are the kinds of things that we've been working on lately.
When you talk about machine learning, and we've done a lot of that on this podcast, it always comes down to trying to make the machine act more human, like process information the way maybe a brain does. How does understanding human behavior, human interaction work into what you're doing?
Yeah, that's a great question. So I do primarily software engineering research. That's the hat I wear, and the epistemology I apply. It's a way of thinking, but I think, how does an engineer approach this problem, and what information do they need? And so I'd say one of the most delightful takes on this that I can talk about from recent work we've done. So back in 2023, we started interviewing software engineers about how they work with machine learning models. And here I don't mean what you learn about in your undergrad class, which is, yes, we have this CNN, we're gonna train it on the MNIST fingerprint data set, and bada bing, bada boom, we can recognize handwriting. How cool. I mean, this is important.
Right.
But most engineers in their day-to-day work are not training models from scratch. They are reusing other people's stuff.
Okay.
Just like in traditional software, most engineers are not writing core algorithms and data structures code themselves from scratch. They're not writing crypto code themselves from scratch. They are reusing those things because they're not crazy.
Right.
And they have to customize them, they have to adapt them, they have to apply the business-specific logic on top of it, but they're trying to build on a solid infrastructure. Saves everybody time, saves everybody money.
Yeah.
The same thing happens in machine learning models. And so companies either internally or they'll take external open source pre-trained models. So pre-trained models is a fancy way to say somebody took an architecture, they took a general purpose data set, they trained the model on that data set, and now it is pretty good at understanding natural language or pretty good at recognizing handwriting. You might need to adapt it to your context. So that might mean you fine-tune the model on your custom data set of internal docs about processes so that you could write an internal chatbot that knows about your company's processes. But you're not starting from scratch. You're starting from something that knows how English language works.
Right.
You might, another adaptation people do is they will I talked about fine-tuning, they'll also distill that model. If it's too big, this model works on a server, but what I've got is this little mobile phone or an NVIDIA Jetson board. I need to make it smaller. So they'll do knowledge distillation, they'll do quantization. There's a bunch of techniques that people apply to try to preserve the general model properties while making it fit on a board. So the study we started in 2023 was trying to make sense of how people are actually going about that engineering task of reusing these models.
Okay.
Right? We know in theory, all these different techniques you can apply to reuse models, but what we were missing at the time was, well, what are people actually doing? Okay, so this is software engineering knowledge, right?
Yeah.
Given this theory about ML properties, how do we actually do it? What are the processes we follow? What are the hazards we're running into? What is hard given the current tooling and the current environment? And we, like any good human factors perspective, we went and interviewed people. So we went on to Hugging Face, which is the premier open source model hub.
What's it called?
It's called Hugging Face.
All right.
It's an emoji. There's actually a paper whose title is, it's like the emoji.
Yeah.
They typed that down and then they were Hugging Face. It's funny to cite it because it puts emoji into your bibliography.
That's funny.
Yeah. So it's got over 1 million models on there. They come from everywhere, right? Major companies like Google and Meta, hobbyists, students in classes, smaller companies that are putting out models to try to build market share, you name it. There's stuff there that you can reuse. And so we talked to a bunch of engineers who are taking models off of this hub and they're trying to adapt them and use them. We tried to understand what challenges they're running into. And one of my favorite challenges that they had was engineers always complain about the documentation, right? Mm-hmm. The docs are bad. You pick your thing. The engineers will say the docs are bad. I can't blame them, right? We all want perfect docs.
Right.
We all want a teacher to tell us everything. But what's very fun about these machine learning models is that their docs are a little bit different from traditional software. One of the main ways that they're different is that the names are very weird.
Okay.
So if you look at traditional software packages that you're going to reuse, they're called things like React and underscore, and mustache, and electron. They have nothing to do with the actual purpose of the package.
Right.
They're just named goofy stuff because you can.
Right.
When you go look at Hugging Face, the models are named things like ResNet 50 V4 distilled images.
Okay.
Those are very specific words,
very
specific meanings. And so when the engineers are complaining about the documentation, one of the things they're complaining about is the names. And I thought this was sort of a funny first world problem, right?
Yeah.
When you're complaining about these names, but they're so detailed, right? Compared to traditional software, you guys are like having a great time here. But when they said that the names are hard to work with, part of what they meant is the names are not always truthful.
Okay.
And so we go look at the documentation, like they're called model cards. It's like the README of a traditional GitHub.
Mm-hmm.
I say traditional. It's like the README of a GitHub project. And it has all these details. And sometimes what they've written in the model name is not the same thing as what they wrote in the model documentation. And then if you look under the hood, sometimes those two things are consistent, but then what they've actually created is not quite a ResNet model.
Okay.
Or it's not like... If you squint, I guess it is, but it's really deviated pretty far from what was thought of as mainstream ResNet architectures.
Gotcha.
And so one of the things that we developed in the past year was a means by which you can take a model and get its name and its model card, and then look under the hood at the architecture and say, are these things consistent?
Yeah.
And then you can say, well, this thing is not exactly consistent, and this thing is really different. And that's very, well, I hope it's very useful to engineers. I haven't tried it on engineers yet, but we have a data set that we can show it's working well.
Yeah.
It's very useful so that engineers who are currently faced with the question, is this model actually what it says on the box? Oh no, I guess I'm going to have to go open it up and look at it. And they're like famous Honestly, it's just a bunch of layers connected. It's really hard to make sense of it.
Right.
So we've offered this novel capability. So there was this problem engineers were having, and we said, well, we could probably build a system that kind of helps them. And so we built the system, and hopefully it helps them.
Oh.
So that's kind of
Yeah.
how my lab progresses. We look at failures or challenges engineers are having, ideally in some cutting edge, most recent domains. Right?
Yeah.
That's where the fun stuff is. And then we try to develop either new processes or new tools or new capabilities that will help them overcome those challenges.
Makes sense. So for students or young professionals that are interested in software engineering and security, what skills or knowledge areas should they be focusing on? And has that changed a lot over the years?
I think that the main thing they should be focused on remains constant.
Okay.
And that is change. Okay. So the thing that has been true for decades is that when you're working in high technology fields, and software drives all high technology fields at the moment, there's no reason that it's going to change. What happens is you get really good at whatever skills and technologies you're taught in your training.
Yep.
That might be coding boot camp you took. That might be your high school AP course and you went off and got a job as a programmer. It might be your bachelor's degree. It might even be a master's or a PhD. But whatever it is, you have this kind of toolkit. And for the next 5 years, that toolkit will remain relevant. You'll be able to get jobs. You'll be a great contributor. But things change.
Yeah.
And if you don't continue to acquire new skills, year 5, you're making great money, you're getting promoted, but at some point, the new folks are coming along and they've got the latest technologies and the latest skills. And if you haven't kept up, you'll be retired.
Yeah.
Possibly forcibly. So the main skill that I would advise anyone trying to get into this field to think about is, how do I keep learning? So one thing that I did when I was a practicing engineer, I joined IBM, right? And I knew I'm coming into this really rapidly evolving space, and I need to stay up to date. And
Yeah.
so I just blocked off on my calendar an hour every morning, and that was Jamie reads a book time.
Okay.
And I got some books, I got some YouTube videos that I wanted to study, and I just spent an hour every day studying those things.
Yeah.
That definitely made me less productive in the first 6 months than if I hadn't been doing that. But boy, did it accelerate me.
Right.
It meant that I had these new ideas. It meant that I was ready to experiment and try new stuff, and that I didn't get set in my ways. And so over 6 months to a year, that started to pay off. After 3 years, I'm proud of this, I held the record for the most defects discovered in a calendar year.
Oh, wow.
Which was in part because of all the studying that I'd done to understand best practices, new tools that I could be applying. And it's not just those things, it's also the way of thinking of embracing change. So that's my advice for anybody. You got to learn stuff. You have to learn specific things to be a valuable contributor in an engineering organization. But you also need to practice that change.
Right. So you're ready for the future.
Yeah.
So you talked about the importance of mentoring when you were at IBM. I know that mentoring plays a big role, especially if you're going through a PhD program. How did mentoring help your educational journey, and how do you view mentoring now that you're in the position of the professor and the person guiding the students?
Those are big questions. So
Yes.
I'll start with the first one. How did mentoring help me? Is that okay?
Yeah.
So my advisor, his name's Dr. Dong-Yun Lee, and he's at Stony Brook University now. And he was a fabulous mentor for me. I will tell you, I studied regular expressions in my doctoral work. Professor Lee has neither before nor since working with me published any papers about regular expressions. But that didn't stop him from being a great mentor for me.
Right.
So he always had his office door open. He was always ready to give me his attention and time. And I would say that the main mentoring role he played was asking me questions.
Okay.
Maybe I could have replaced him with a parrot that said why over and over again. I'm kidding. But just that, having somebody who is on your side rooting for you and is pushing you to be the best version of yourself, who's pushing you to produce your best work,
Yeah.
and who's holding you to a standard far higher than you might hold yourself, and also higher than your I don't want to say competition, but other researchers in your field are being held to.
Right.
Right. That will help you grow past where you think you can. And then when you fail, there's somebody there to help you pick up.
Right.
And try again. And boy, did we fail too. Don't worry.
Yeah.
So that's really shaped how I go about mentoring. Right. So I too ask my questions why a lot, and maybe they could replace me with a parrot too. But I try very hard to be attentive to my students. I try very hard to push them, like Dr. Lee did for me. I try to push them to be the best researchers they can be. And I know everybody has different limits, and everybody
Right.
wants different things, right?
Yeah.
Some people want to be a professor. Well, we're going to push pretty hard. If you want to go off to industry, I'm going to push you to do internships. I'm going to push you to develop
Gotcha.
your network,
Yeah.
right? So different people need to be pushed in different directions.
Yes.
And I think that a lot of my job as a mentor is to understand where my mentee wants to go, and then know the path that other successful people have taken to get there, and to help the mentees see that.
Gotcha. And be willing to, what your mentor did, do something maybe is not their first interest, but
Yeah.
help them, like you said, get to where they want to be.
Yeah, and some of my students want to study topics I don't know a ton about, right? So I go do my homework, I have conversations with ChatGPT, I look up Wikipedia, I read
Yep.
some research papers that I wouldn't otherwise have looked at.
Right.
But I find that when a student wants to work on a project because they're passionate about it, that produces the best results.
Yeah.
And so to the extent that I can develop enough expertise to help them work on those passion projects, it's the best outcomes.
Yeah, absolutely.
And that requires some work from me, and I'm willing to take it on.
Well, and it's also, like you said, it continues your learning too, because maybe you would never have learned about that topic, but you are because of your students. So
Yeah, that's exactly right. And another cool thing that happens when you're willing to, again, keep embracing new things and change is you see potential synergies between different lines of work that your
Right.
students are doing. You know, on paper, these things look very different, but because you're in the thick of it and you're learning these new things, you can say, oh, you two should talk about this.
yeah.
And while we're at it, I just had an idea. Let's get a third person in here. And you start to develop crazy stuff because you're willing to push the boundaries on a couple different topics at once.
Yeah. So you spend a lot of time teaching, mentoring, researching. When you're not doing any of those things, what kind of things do you like to do to just relax, have fun, take a break?
This is a sensitive topic in my household.
Oh, okay.
My wife contends that I do not relax or take breaks. I do relax and take breaks.
Okay.
There are perhaps 3 primary outlets for me. The first is I have a 2.5-year-old. His name is Hugo. He's amazing.
Yeah.
We go to the hardware store together and we buy things and take them home and assemble or disassemble and paint
Yep.
and all kinds of stuff. So he's really fun. The second thing is I sing in my church choir.
Okay.
So on Thursday nights, I go to the St. John's Episcopal Church Choir, and we practice for 90 minutes, and I'm in the tenor section there, so that's really fun. And the third one, I did have a third one. Oh, I like to cook and bake.
Oh, okay.
So on the weekends, we'll do experimental meats or try to make kinds of bread we haven't made before.
Is that something you've always done? I know a lot of people over the pandemic developed their cooking and baking skills.
Those are Johnny-come-lately. We were doing it before it was cool.
Gotcha.
So
I gotcha.
We've been doing sourdough breads and other kinds of breads since we got married back in 2012. And actually during the pandemic, you couldn't buy flour, right? Because
Right,
everybody
yes.
was getting into baking, and we're like, well, we've been doing this the whole time. So we actually bought a flour mill online.
Really?
And we bought wheat berries.
Oh my
'cause nobody
gosh.
was buying up the wheat berries, so we got straight from the source. We got the flour mill, and now we mill our own flour.
Well, you were really into it then. You're not kidding. So, and biking, I know you bike a lot. Do you consider that a relaxation thing or just merely a transportation thing?
I wish to live for a long time. I do enjoy biking, but I don't tend to go on long bike rides. More like short and fast ones.
Yeah, gotcha. Get you from point A to point B.
Yeah.
Well, thank you so much for joining me today for this conversation. I really appreciate it.
It was great to be here, Kristin.
And that's all for this episode of Engineering Innovations. You can check the show notes for links to the Purdue ECE website and to our social media platforms. If you enjoyed this episode, please subscribe, like, comment, and share all the things. It helps us bring these fascinating conversations to even more listeners. Also, we'd love to hear your thoughts and suggestions for future guests or topics, so be sure to reach out. We'll be back next month with another new episode and another inspiring guest shaping the future of engineering. Until then, I'm your host, Kristin Malavenda. Thanks for listening.